Hello, we're back.
We're back.
Back with Leah.
A long time no
Yeah,
see.
it's been a few weeks,
Yes.
but we have Leah on as actually our very special guest
Oh yeah.
because she'll be talking today. Well, today is all about machine learning,
hmm
webcam integration, and some very, very exciting things that we're working on for Quinly.
Yeah.
And this is a project that how long have you been working on it now?
Probably like 3 months.
Yeah. So it's like finally coming together. So it's
Yes.
going to be very exciting. So just while we wait for people to come in at the beginning here, yeah, we're going to talk all about machine learning, machine vision, how it applies to 3D printing, and how we plan to integrate it with Quinly, and also like all the value it can bring. Um, yeah, I guess if you have any questions, as always, make sure to post them in the chat. Like Jack has, for example, saying masks again. Last week was no masks. Well, unfortunately, they walked back the guidelines here after 1 week of freedom.
Yeah.
Apparently, the people of British Columbia were not responsible enough. So now there's a new mandate, a new safety mandate. So the one ever stream we did without masks, we've reverted. So yeah, it's pretty unfortunate. Um, but hopefully it won't be a thing for too long.
Yeah. ASMR.
Okay. So why don't we just get right into it? So why don't we talk about what have you been working on?
Okay. So basically, I have been working on a machine learning model that will hopefully be able to detect failures in 3D prints as it's printing. And unlike Spaghetti Detective, we're hoping to do a bunch more types of failures because a lot of the time spaghetti happens after different kinds of failures. So if you can catch it earlier, it's always nicer
Hmm.
because of like obvious reasons, like you don't want to waste your filament and like your time, everything like that. So that's what I've been working on recently.
Yeah, I think that's going to be a very important um, theme kind of for how we've designed our system is going to be it's meant to be a preventative system that will at least try to catch failures either like before they become massive and turn into spaghetti
Mm-hmm.
or to notify the operator before there's like potential damage to your machine too because spaghetti tends to mean like either your parts fallen off or your extruder's gone completely out of position and if you leave that going for too long, that can, cause problems with the hot end, cause
Yeah.
problems with the motion system. It's just not really good for your printer. It can throw it out of calibration too. And what's really important in the context of automated printing is because we don't want an operator to be constantly monitoring and babysitting their machine over a live feed,
Mm-hmm.
we need to have some sort of way of automatically um, detecting these types of failures or things potentially going wrong and so that you can notify the operator.
Exactly.
Just
Definitely have like messed up a lot of our printers already just by trying to get the data. I know
yeah.
that Sanford like told me one of mine was like really failing and I was like, "Oh, is that bad or is it a bad one or is it
Yeah.
like can I leave it?" And he was like he didn't really respond because I think he forgot about it and he fixed like what was wrong, but then like an hour later the same thing started happening and I didn't know it and he wasn't there anymore and I came back and the nozzle was completely covered in
Yeah.
filament.
Yeah. So that like having some kind of automated response to those kinds of things can help save um, your machines, but also just save you or your operators a lot of time because fixing like gunked up hot ends is such a pain, honestly.
Yes.
A lot of people actually I know a lot of like people who operate machines, they'll just throw the hot end away
Really?
because it's too much work to extract it.
That's pretty fair.
So,
I showed Joe and he was like unhappy when I
yeah,
showed him.
Joe's not happy. Like, yeah, I would imagine he wouldn't be happy with that. But yeah, it's like it's come to the point where um, dealing with failures and finding out about them so late into when they happen, uh, it's like it's less expensive to just throw away certain components and replace them, and that's what people in print farms, that's how they deal with it, and it's not like it's incredibly wasteful, and
Yeah.
it's also very inefficient too. So yeah, so when we talk about this model, the whole point is preempt these failures and then have Quinley react depending on what kind of failure it is.
Hmm.
So we're going to go into our first topic is like, I guess we kind of talked about it. Why do
I
you,
mean, there's more specific
there's
stuff
more
still.
specific things, but why would you want a 3D printer to know when your parts are failing?
Yeah. So like there's like a few different ways you could look at it since there's so many kinds of failures. There's some that are like catastrophic like we were talking about, and those ones you would probably want to like abort obviously.
Mm,
And then
just stop the printer.
yeah. And like if it's something where like you can wipe it off by like just doing a wipe with Quinly, then you can wipe it and then just restart it. Like Quinly would be able to do that if we have this kind of model. And then there's also different other kinds of failures. So like things that we could compensate, like maybe the type of extrusion that's happening, it's over extruding or under extruding, that we could hopefully try to compensate for if we knew that it was happening. And then like lastly, just like notifying in general, like some people have different qualities of prints that they are okay with. So you don't want to like stop it just because of like a small failure and you that you could fix probably. So just giving a notification to someone who's printing something and letting them decide whether or not they would like to do anything about it basically.
Yeah, the whole point is not for, Quinley to replace your decision making in terms of what parts are coming out, but it's really just to help you become aware more quickly of, or to become aware of potential failures. So like in an example like stringing, you might just have, a pet G that is really
Mm-hmm.
stringy and you're printing it fast. And so it might detect stringing, but you can set a really high threshold for it to actually automatically abort it. Or
Mm-hmm.
you could say, just notify me, maybe pause the print when it strings and um, let me check to make sure it's okay.
Yeah, exactly.
So that's how we plan on implementing it once the detection is all set up. And actually, we'll go into this shortly. But unlike Spaghetti Detective, like Leah mentioned, that just looks at spaghetti, we're actually looking at 14 different classes of print failure, and we'll go through that list later. But just by knowing that, you can already see how certain classes will solicit certain responses from the system.
Mm-hmm.
And because the whole point of Quinley is scaling your time to more machines, you can imagine having to monitor, a farm of 20 machines at once would get very overwhelming quickly.
Yes.
But if you had a dashboard that's like, oh, this machine, there's some part warping, or this
Mm-hmm.
machine, there might be stringing, and it helps direct your attention to where it's most needed, it can save you a lot of time, and it can save you, um, like in bigger print operations, it would save the need for having operators spend time monitoring the machines when they could be doing more effective things like slicing more parts and
Yeah,
things like
for
that.
sure. And like I think building onto that as well, like if we're able to log all these failures and everything like that, then we'll be able to analyze maybe like if there's something actually wrong with the printer in general.
Hmm.
So like maybe like there's weird stuff happening in the first layer, so your bed is obviously having an issue and maybe you want to re-level it or something like that. They'll give you some sort of alert that maybe you want to actually fix your printer instead of just like restarting and
Yeah,
printing the exact same thing.
no, that's it's exactly that. Like being what Leia has done, with her ability to detect what's going on, um, is the first step of closing the loop when it comes to 3D printing, so that, yeah, so that you can see, maybe you have a farm and one printer is under extruding more than normal, and then you can, like, if it's under extruding more than normal compared to the rest of the machines, and the other machines are all, printing similar parts and similar
Mm-hmm.
materials, you can then direct or send a notification like, hey, you might want to check out this. Could be a nozzle clog, a
Mm-hmm.
thermistor issue, and actually have it point you into the right direction. And where this becomes interesting is when you think about like what is the actual um, expertise and knowledge required to run a print farm,
Mm-hmm.
because usually the people, at least the people we speak to, that are running larger print farms are not necessarily that technically focused. They want to run printers for their business,
Yes.
and so they don't want to spend hours and hours troubleshooting weird issues. So if we can help detect issues and then use our knowledge and community knowledge to
Mm-hmm.
guide people to potential fixes, yeah, it can save everyone a lot of time.
For sure. And even like beginners, I feel like don't even know the names of some of these types of
Oh my
failures.
gosh, yeah,
So it's just like, like there's like things coming out.
yeah,
Don't really know how to Google what to do.
yeah. They're like, why are there branches coming off my print? And then you Google it, and there's like no,
No
no
results.
results. I remember when I first started 3D printing, I was having this issue where, um, so I had a square infill, and my top layer would have little bumps wherever there was an
Hmm.
infill, and I didn't know what that was called.
Yeah.
Like I couldn't find it. I was like bumpy top layer, and then I just get links to over extrusion, and
Sad.
I actually had to. I made a forum post, and I just had to wait like 3 days for someone to respond.
Sad.
Yeah. And it turns out it's called pillowing, and it was because my first layer,
Oh,
my top layer was too hot
another
for,
thing to add to the
yeah,
list.
another thing to add to the list. But it's like it's stuff like that that wastes a lot of operator time and can even hold up production. Like
Hmm.
if you don't know what's going wrong or what something might be called, it's a pain.
Yes,
Yeah.
I agree.
That's why there's so many communities dedicated to just troubleshooting issues for you.
Yeah, exactly. Or just like huge, like long pages that show you every single failure, and you have to like look through each one to find the one you're
Yeah.
kind of
It's
thinking
not fun.
about.
And that's not to discredit the guides out there. That's what we've had to build up in the industry in order to actually be able to run machines.
Yes.
But being able to incorporate those guides and tie them directly to like a detection system is what's going to be very interesting.
Mm-hmm.
So I guess our next topic is how is this different from something like Spaghetti Detective? And we mentioned it a bit before, but maybe if you want to elaborate.
Yeah, sure. So like basically like I think Spaghetti Detective is insanely good for like what spaghetti is. Like I think it happens a lot, so it makes sense for them to start there for sure. And like it's spaghetti has like a very obvious kind of look, I feel like. So it's like really cool that they're able to do it so well. And what we're trying to do is like basically adding on to that in a
Hmm.
way, like trying to find other situations where failures occur, but they maybe spaghetti never happens from these failures, or they happen before and you just want to kind of know about it earlier than before, like the entire model is just extremely aggressively messed up.
Yeah.
So that's kind of where we're going, what we're going for, and we're also hoping to in the future get some temporal kind of model in there. Right now it's not. It doesn't really detect what has come before it. It's detecting frame by frame. But
Hmm.
if we're able to have something that can see what has happened before and what is happening now and comparing it, that will make the model even more predictive than like anything that I've seen before, at least.
Yeah. Yeah, that's a good point. There's not a lot of models out there that take that because you want that context. That context can
Mm-hmm.
be really helpful. Actually, why don't you grab that gray tube and I'll show you what we mean. So we'll go into like how we made this later, but this is just an example of a part where there was actually only one failure in this print, and what happens is oftentimes when a part has an issue, it cascades into more and more issues. So this print was actually just a layer shift issue,
Just one.
a single layer shift that was intentionally triggered right at the bottom here. But you can see over time, because the printer didn't know, we just let it go. Over time, it causes this weird overhang, and then the model keeps building up, and then it warps, and then causes another layer shift and another layer shift. And in a lot of cases, it ends up becoming spaghetti, which is what models that are out there detect, which means it's like a very, very delayed detection, which means you lose a lot of material in the process.
Yeah, clearly it was stuck on real good because it didn't just all fall down.
The fact that it didn't get knocked down is pretty impressive. But yeah, it's like small errors cascade into bigger errors. So if we can catch these small errors first, we're not wasting print time, we're not wasting material, and we're able to even potentially save the machine. Yeah, so I thought this was a really good example. And actually we can move on to specifically like how many ways can I print fail? So if you read the title of this stream, you'll know that we've been causing many, many intentional failures. Do you want to show the
Yeah. This one of my favorites, but one part is missing. There's some good under extrusion. I don't know if you can focus.
No, it's not autofocus.
It's fine. They can kind of tell. Or there's a good layer shift egg. I thought this model was pretty cool by itself, but
hold it over the yellow. Yeah. And we'll show some close-ups of these parts actually.
okay.
Are you guys gonna discuss using reference geometry? Yeah, so we'll talk about that when we talk about future things, but reference geometry is going to be a big component of this. Anyway, Leah's got a big box of failed parts, and I'll actually show you. So what we were doing is, well, it's kind of hitting two birds with one stone, which was implementing time lapses with the PyCam and also intentionally causing print failures. So you can see the 14 types of print failures this isn't all 14 actually. Do you have the list of 14?
Those should be all of them, but some of them
are
technically like not failures. Like some of them are like model. So model is so like you can track where it is kind of.
Yeah.
And then compare that to where the failure is, because like if you just have a little bit of spaghetti on the side, I kind of want to be able to be like, well, that's not affecting the actual print though.
Yeah.
And stuff like that. And then there's also skirt, because sometimes it like it adds spaghetti and I don't want it to, so I just wanted to force it to detect the skirt.
So let's walk through them. So there's obviously the big one, spaghetti. Something's really gone wrong if you're getting spaghetti. And then there's layer shift, which is actually fairly common. Warping, huge one. Stringing, under extrusion, over extrusion, nozzle blob, poor initial layer, poor bridging poor overhangs, part detach, which is
that one's gonna be hard to do.
That one needs the temporal contacts.
It does.
No extrusion, which is also really important to catch. Skirt issues and also zits on the side of the print. So how do we want to break this down? That's a lot of categories.
I don't even know.
Most of them are pretty self-explanatory. I think one of the very interesting ones, at least to me, are the ability to catch under and over extrusion as well as a nozzle clog, because that kind of thing, if a printer doesn't know that its nozzle is clogged, it might continue doing prints without actually printing them, which causes like you'll suddenly come and count your parts and you will have the wrong number of parts, which can be really annoying for inventory.
Yeah, for sure.
But then with the under and over extrusion, why don't you explain like what can we do when we know that that's happening?
Yeah, for those ones, like hopefully we could compensate like with ESEPs or something, because that would be really nice if you could save it instead of just restarting, or like if that's something you can kind of just push through, like for for under extrusion, like then you wouldn't have to go and fix it. You could just like stay there where you are, not going to go fix things. So that would be ideal. But right now, I know that the under extrusion, we got some good prints of that, but the over extrusion, I still have to figure out more, I think, because it either like is too much and it pushes the entire model off and I barely get a print, or like you can't even tell, it looks like exactly the same as a
Yeah.
good print. So I need to find that really good balance.
And that's a tricky thing too. Like, yeah, being able to catch that and make live adjustments, either by notifying you to make those adjustments and giving you an interface to do it like while the print is happening,
Hmm.
or even building it right into Quinly itself, and like if it is under extruding, try a higher E steps. If it still looks bad, then there must be something wrong with the
Yeah.
nozzle. But if it fixes it, then you're happy,
Yeah,
right?
exactly.
So that kind of thing is what we want to implement. And it's like it's all foundationally based on being able to see and understand what is happening.
Hmm.
So Leah's printed like hundreds of hours of failed prints.
Hmm.
Just like you basically, what did you say? You downloaded like the first 3 pages of
Yeah,
Thingiverse
I've
files?
downloaded so many that it's like I need to make a script where it just like sifts through the files that and like knows which ones I've already printed, because I'm always scared that I like forget that I printed that
Yeah.
already, and I don't need extra data on the exact same model. So finding new models and like having to slice them all is like more of the issue now since I've automated everything else.
Is that our next topic? Is it?
Oh no.
Oh no. There are some
Oh,
questions.
question.
Let's answer these. How accurately can you detect under and over extrusion with that angle level of camera quality? So what's really cool about machine vision is that with enough data, and we'll talk about volume of data in a second, but with enough data, you're able to actually recognize these kinds of things fairly easily. Like the images that you use are fairly low resolution. I think they're
Hmm.
600 by 400
Yeah.
pixels, right?
Yeah.
Even though the camera is HD. And as you refine your model, and maybe it'd be best for you to jump in here, but
Yeah.
from what I understand, as you refine the model, you can work with lower and lower resolutions. And there's also ways that you can process the image in order to expose these kinds of issues much more, like
Yeah.
much more. I th
Yeah.
I think a good example of it would be like, you know how with when you print in white filament, you can see extrusion issues super
Yeah, yeah,
easily.
yeah.
And so you could do something like turning up the contrast in the image and
Hmm.
looking at stuff like that.
Yeah, that has like we've kind of accounted a little bit for that for like data augmentation as well. So like one thing that you do when you don't have enough data for different models is you use the same data, but you change either the brightness, you crop out certain parts, you flip it, you like kind of turn in different ways, and like
Hmm.
that is how you get more data. And that's kind of different, but still similar. And for our resolution, I think you're able to see under extrusion pretty well just because like of the way we focus the cameras and stuff, and like um I've been able to see it like myself, so I feel like the model will be able to understand.
Yeah.
The over extrusion is a more difficult because I can barely even tell myself. So that one will be interesting. I also think it's like if it's so minimal over extrusion that I can't tell, then
Yeah.
I don't think it's that much of an issue.
I don't think, yeah, like because over extrusion becomes an issue when it like destroys your part.
Hmm.
Otherwise, it might, mess up the dimensions of the model. And,
Yeah.
and that's not possible. That's not really possible to detect with like a pie cam.
Yeah. I mean, I can't do that. I can't be like, oh yeah, that's a millimeter
Yeah.
off. Like,
Yeah. So another way that we're looking at detecting things like over extrusion and extrusion issues in general is by monitoring non-visual things like stepper current and seeing like does the stepper current suddenly explode partway through the model and like just something's grinding in there, or does it suddenly drop while it's extruding and then it's grinding. So there are other um, areas of the printer we're looking at for this, not just visual monitoring. But
hmm
visual monitoring is nice because you get really a really broad range of like qualitative feedback.
That's true.
And we'll show some of the results of the model shortly as well. But I think it'd also be good to talk. Do we talk about how we're getting all these
Oh yeah, it's
failures?
at the very end.
Oh, it's at
We
the
have a
very
lot
end.
of stuff.
Oh yeah, okay, okay, cool. Okay, we won't go into that just yet.
Okay.
But well, it wasn't just Leia's slicing profiles are not terrible, I swear.
It's not just me
Yeah.
really bad at my job.
Yeah. Okay, so what is the difference between 3D print failures in one-offs versus in production, and why is it important for automated 3D printing? So I think I'll take this
Yes,
one.
you take this
Yeah,
one.
I'll
I don't
take
know
this
that
one.
much about production, to be honest.
So, like the failure detection itself, as we mentioned earlier, is really useful to anyone doing 3D printing. Um, but it is extremely useful for production on Quinly because like production, but especially automated production, like with Quinly, because as soon as you switch to automated, most people are printing 2.5 times more per day than they were before. And like if you just think about it, with a manual printer, if you suddenly want to print 2.5 times more, you'll have to monitor it 2.5 times more. Whereas we don't want that to be the case with Quinly, so we want to make these tools to assist you um, with any sort of increased labor. So we've Quinly already eliminates the need to go and remove parts, and it helps with printer calibration too, because you're not always fiddling with the machine. But there is still this issue of poorly sliced parts or just machines wearing down, and you don't want to have to monitor your printer 24/7, even though like Quinly's already reliable. We want to make it more reliable,
Of course.
and we don't want it to your printer to get damaged, because I know something that I've done with my Quinly is I'll literally let it run for like a week, and I'll go downstairs and check my bin of parts and realize like, oh, everything was going really well except this one part just was sliced really badly, and uh layer shifted because I was over extruding in my walls or something. And like if I had a detection mechanism and I wasn't just staring at the stream 24/7, I could have been notified, hey, you might want to reprint this part again because something went wrong with it, even though all the other parts went fine. And so it's that kind of thing that can cause really big production issues, because now what you've submitted to the printer might not match up with what you actually got out of the printer. And you want to be able to catch that as soon as it's happening so that you can plan for it. I think another thing we talked about earlier is just if you don't catch failures, you end up with a lot of waste. And because a person has to deal with that waste and deal with potentially repairing the machine, it also essentially doubles the cost of your part. Like if you let a print, because you're running a farm, you don't have time to constantly check printers. You let the print run to completion and it shifted partway through. You've now got an entire batch of prints that are just effectively useless.
Exactly.
Whereas, yeah, if you caught it earlier, um, you could have stopped it right after it shifted or potentially tried to recover it. And yeah, waste is bad for the environment. Increased labor requirements, like increasing your time spent doing very menial labors, is not a good use of your time, and just makes your parts really expensive and makes it hard to actually make money from 3D printing. And the other thing is, it's because failures can be unpredictable and take a while to get caught by a manual operator, it results in longer lead times. And I think up until like 3D printing itself shortens lead time so much compared to regular manufacturing that most people are kind of fine with something failing every so often. But that's because 3D printing is not really deployed on a massive scale yet. And so when it is actually used as a production method, that kind of thing is not going to be tolerable anymore. And so you don't want to have these freak failures going uncaught and constantly extending your lead time. And then the other thing that happens, which I know I have done before, is just produce way more parts than I need, which is also wasteful and just consumes resources that could be allocated to other things. But I'll make extra prints if I know it's a print that might frequently fail. And so that can cause problems as well. The other thing is, if you know which parts have issues in your workflow, like in the Quinly workflow, you're able to sort them out and detect them much faster. And I think there are some very interesting automated downstream part processing. That's like a mouthful of words. I'll say it and then I'll explain it. There are a lot of automated downstream part processing technologies for 3D printing. And what that means is there are systems that already exist, that are already in use by some manufacturing facilities that take like 100 3D prints, detects them all, and sorts them all into
Oh,
boxes and classifies them, which is yeah, super cool. It's used in the powder bed industry because you're often dealing with 1,000 parts at a time there. But and usually when a batch fails in powder, it's usually either the whole batch or nothing. You don't end
okay.
up with like random failures too much. And so that works for that. But with FDM, like being able to say to that system, like, hey, this part I'm clearing off, it failed. We don't want to process it downstream. We want to kick it out. Quinley can now say that to the downstream um, systems, and so that they know, like, okay, here's a defective part. We know from the machine itself that it's defective. We don't have to build a complicated system external to the machine to see whether it's defective or not. We don't need like a fancy QA process.
I see.
And then like you can do that kind of thing when the failure detection and QA is built right into the printer. So that's like a very exciting future thing that would just help 3D printing fit in other types of manufacturing. You're not building your entire facility around the 3D printer because the printer already has the tools to be able to give you this information.
Cool.
Yeah. So recap what's going on for any newcomers.
Oh.
Oh yeah, good catch. So for anyone that's just joining us, and looking at these beautiful failed prints behind us, we're talking about how we're building a detection model that detects 14 different types of failures on a 3D printer, and how that can be used to further automate 3D printing and integrate it into um, like a manufacturing line or just for final products.
You're good.
Anything I should add?
I don't know. I think we'll probably get more into it and then
Yeah,
like it'll all make more sense.
yeah. But that's just a quick recap.
Yeah.
It's like the failed prints you're seeing around us and above us are intentionally paused
Yes.
because we want to
It's all
know
data.
it's all data. Yes. Yeah.
There's a question actually from Deanna about if you printed any design files like specifically testing like overhang issues. There's like an overhang challenge test that you printed or a bridging test challenge.
Um, I mean, there should be one. I just haven't done a lot of them yet. It's more like things that I haven't added supports and stuff to, and then like I would catch those, but that is one thing that we would be cool to automate.
Yeah. Yeah, that's a good point. You could print like insert a reference part some point in like in your queue. You have a queue of 100 items and you want to make sure your machine's still working. Maybe every 15 items you get the printer to do a reference calibration part and check and detect whether there's anything wrong with it. That could be really cool. But yeah, most of these models most of these models that we're doing were just like grabbed off of Thingiverse, and it's meant to portray like a failure on a realistic model someone might print. Salt City Dom is saying, I'm literally watching the stream as I'm slicing models and throwing them onto my machine in a different part of the house.
Very nice.
Yeah, very
Very
nice.
nice.
Cool. That's awesome. Um, okay, so yeah, let's move on to the next section, which is now like diving into the details. So we can detect the parts, we have ways of dealing with these failures, but like how do we actually know when a part is failing? So like what is machine learning and what is object detection? And I'm
Yeah.
gonna switch to our other really cool view. We figured out how to do chroma keying for this stream. So we're like floating in
Be
the
impressed.
images. Yeah. The production quality is out of this world.
Yes, yes, yes. So, machine learning is, I feel like, something that people use the buzzword a lot, and like nobody really knows what it means.
Yeah, it's like lost. It's lost.
It's lost its meaning.
Yeah, due to overuse for sure.
But it's basically like an algorithm that has a lot of math in the background, which like I mean makes sense. Obviously, there has to be some reason why like it can allow a computer to learn things, and in a way it is learning kind of like a human. It's maybe not as sci-fi as you might think, but it kind of the way that it has neurons is like similar to how like a human has neurons. So the way like a human has like brain activity in a way is they have different neurons and then they process data. So the data is received and then there's some sort of chemical activation function in your brain that allows the data to either be transferred or not to the next neuron. So by doing that, you kind of learn like about the data that you receive and if it transfers or not. So it's similar in machine learning because we have that structure as well. We have a neuron. They also call them like nodes or neurons. They're like they use the same naming kind of. And it has all these kinds of data that comes into a neuron and it has weights and biases multiplied and added to the different pieces of data. And then once that is all like mathed out in a way, you sum it all together in the neuron. And then there's an activation function as well. It's a mathematical one, but it is still an activation function. So it also does the same thing where it like kind of says yes or no to the data, and then the difference between like I don't really know how humans work that much, but like the difference between that and us, I guess, is that we have forward and backwards propagation while we do this algorithm. So that uses like a bunch of calculus and stuff, and it basically like kind of compares whether that idea that it had is correct or not. So like if it passes it through and like let's say that means like 1 versus 0, then if it matches the 1 to the true answer that you give it, then it's learning correctly and you should say this is like it's learning properly. If it's wrong, then it goes backwards and tries new different kinds of weights and biases to see what is the most important pieces of data that give you an answer that is correct, basically. So for any machine learning model, that's kind of how like the basics work. And then you can apply it to different types of data. So right now we're doing an object detection model, and that kind of model uses pixel data instead of like, I mean, pixel data is numbers technically. So we break it down though. Like when we look at a picture, it's obviously not numbers to us. It's something visual, but to computers, we're trying to make it easier for them to understand. So we break it down into pixels, and these pixels have color values or they have just like black and white values depending on what kind of pictures you have. So if there's colors, then there's 3 different channels of colors like the red, green, and blue. Blue. And then for the black and white ones, obviously it's like just one color channel. So it basically kind of uses these different numbers and does a kind of matrix algebra on them to kind of pull out the key features in a way. So they have these filters that you can convolute over the different pictures that you feed it in, and then that allows it to see like edges and then slowly after edges it can see like maybe simple shapes, and then after simple shapes, like maybe if it's a human detector, like a nose or an eye or whatever, and then finally like an actual face after you bring it all together after it's gone through the many different layers. So that's kind of how what we're doing works, and how I guess we don't have eyes, nose, whatever for our
Yeah.
model, but it is like seeing like spaghetti. Oh, it has the edges of like the spaghetti strings, I guess. And then like, oh, it's not just like a bunch of edges. It's like a whole like curly kind of spaghetti looking thing with edges. So that's kind of what it's trying to figure out, basically.
Yes. So, yeah, if I got it right, it ingests this image, and then it usually it compresses the image,
Yes, yes, yes.
and then there are different layers of neurons, and like at the lowest layer, I guess where there's the most neurons, are very, very tiny features
Mm-hmm.
of the image are being detected, just like edges in different orientations. Um, and then slowly, as you add more and more layers, those neurons feed into larger features comprised of those
Mm-hmm.
edges or changes in color. And eventually it builds it up into something that is actually comprehensible.
Mm-hmm.
Like, I guess, yeah, your analogy of a human is good. Like,
Yeah.
if it has two eyes and a nose, it's probably a face.
Yes,
And so the
exactly.
the face neuron will be like, okay, it's signaling mostly a face, so I'm gonna say it's probably a face, and then it just keeps
Exactly.
feeding up like that.
Yeah. So it's kind of learning, like, but I don't know if like a human would learn like that, but that it's learning in the way that it knows how to learn.
Yeah, we had some good comments too.
Ooh.
Ben was saying we should directly feed it into IBM
Oh
Watson.
my God.
Uh, the thing about, I don't think, I don't know if any, gosh, IBM Watson, the budget for that would be insane.
Oh, for sure.
It's got a, I know it's got a, it's like a, there's a reputation for that platform being extremely expensive. So right now our the GTX 2070 Super is what we've
Yes,
got.
that's all we have. I mean, like, that's pretty good for a
It is.
graphics card, but it's like, it still struggles real hard, so we
Yeah.
need to get multiple GPUs on this case.
And Justin 3D asks, is this a plugin for Quinly? Yeah. So this is something that we actually plan to launch um, for all Quinly users.
Yeah.
So this will be in there, and then yeah, so you'll be able to that's why we added the camera stream. So that the camera stream and also your printer will actually be able to react to things going wrong, which is really critical for for automation and for running 24/7. If it has two eyes and a nose, it's probably a Moai model.
Wait, did I
I think we
this
printed
one?
one. Oh, not that, not quite.
I don't think I have
You
one
don't have it?
face similar to that.
You can show the green face. So.
Yeah. I have this face.
Wow,
It's
green.
a planter.
Yeah, it actually turned out that our yellow wall
Yeah. Aren't
is
you
a really
impressed?
good green screen.
All of these
Oh, here's
prints
the
are
Moai.
green right now because I had a bunch working pretty well in green. So,
We do have a Moai, but it's
oh, just
like,
a small boy.
yeah, he has no eyes, just a nose and a mouth.
Yes.
So kind of the opposite.
Yeah. But this one could do the same thing.
Cool. Okay, so next up, we've gone through all of these actually.
Oh yeah, I kind of just went through all of it.
Awesome.
All in one time.
That's awesome. So, okay, so in terms of our project specifically and why we decided to do this from the ground up, a lot of people ask us this for a lot of the things we do. And it's because it's built around the automation. And same thing with Quinly, and why we built it the way we did is it's built to facilitate automation and it's built to scale. And so one of the questions that when we've discussed this with people in Discord, they ask us is why not just improve Spaghetti Detective, or why is there nothing beyond Spaghetti Detective? Like, why can't you do more than Spaghetti? And I think one of the biggest reason is that there's simply not enough data out there.
Mm-hmm.
These training these models is like I have to say it's a pretty inefficient process. Like,
Yes.
how many images have we captured so far?
I think like 225,000
Okay,
from time lapses, but then the actual annotated ones is like 2,000.
yeah. So we have 250,000 images that we've had to capture, and so far we've only used 1% of them in training this model, which is insane to me. And it seems to be doing pretty well. Like I'll go back to this, but here are just some of the examples of the detection that we're getting so far with just 1% of the data we have.
Yes, it could be further improved for sure, but some of them have been like pretty good, honestly. But other ones, I'm like, what are you talking
Yeah.
about?
And it's a massive problem. Like, luckily, things like spaghetti are so distinct that it's very easy to train them. Like, I know you had a model a few months ago where it was able to detect spaghetti off of like 60 images, right?
Mm-hmm. Yeah.
It's because it's so distinct. So one of the biggest issues is like where do you get all these pictures from? And that's where we've been really, really heavily leveraging our ability to do automated printing. Like this is my favorite thing is we actually Leah's created scripts that takes good G code, turns it into very specific types of bad G code with very specific failure types, and then we're able to just queue a bunch of them up and automate all of the data collection for that. And so those 225,000 images were taken using only 3 printers. So just imagine like if you have a farm, if you've installed this on a farm, which I think we plan to do, um, of 20 or 50 machines,
Mm-hmm.
how much data you'd be able to get in from that, and that will only make the model more and more robust.
Yeah, exactly. Like data is like something that's pretty insane that it like how much it needs in a way. Like even though there are some models that like they don't really need that much because either they're really optimized, like
Yeah,
the ones with the numbers, like how you were saying,
yeah,
and then there's also like ones where like cats and stuff are just like kind of in a way easier to identify because of their color or their like facial shape, their body type, things like that. They can be small, they can be big, but like in general, a cat looks like a cat. But compared comparing that to 3D prints, every model can look extremely different.
they can be
Like
different colors, different. They're always different shapes.
yes.
The whole point of 3D printing.
Yeah. So it's like really difficult to get a model to generalize everything and like still be accurate in a way
Mhm.
because that's why we just need so much more data than you might think and why like this process is just going to be a bunch of data collection at this
Yeah,
point.
yeah, just as many, yeah, pieces of information we can get about our prints and cataloging them. And the excellent thing, I actually will go into this next. I won't talk about it, but we've found ways of automating it because if you think about it, like right now, a lot of that data collection is manually done. So people are literally starting prints, taking photos of prints or taking time lapses of prints, clearing them, starting the next print, and that is like extremely expensive and extremely time consuming. And that's simply why there aren't models that are that good yet available. And like yeah, for I mean a lot of the people watching can probably attest to this, but if you're running Quinly, printing a few thousand things is not that much of a problem. I
Mm-hmm.
was talking to oh, I forgot his name. His It was Machine Creators, and he was doing a job where he had printed something like he was printing at a rate of 55,000 parts per year on
That's
3 printers. But he was printing for a couple of days. But if he had maintained that rate,
Oh,
he
okay.
would have gotten 55,000 parts that year, which
Damn.
is insane. It's like a few hundred parts, or it's over 100 parts per day, um, which is like yeah, way more than any single operator could hope to do. And because putting Quinly on more printers doesn't increase your labor, just tacking on Leah's automated image collection to each one of those Quinleys, our image processing, uh, is super easy to do and very scalable on a budget, which is important for startups.
Yes.
So yeah, the Quinly system and the automation system really, really, really helps the issue of lack of data. And I mean, if you look at just machine learning as a whole, the companies that are pioneering it generally have access to a lot of information.
They really do.
Yeah. So if we're able to generate a lot of our own information in-house and train our models off that, then we can end up with a very successful model. So that's kind of how we've managed to generalize it more. Yeah. The problem space is so insane. It's like anything you can think of that can be printed in any color, including like reflective colors and transparent colors. And you have to be able to have a model that's that general. You're gonna like build an AGI. And yeah, who said, someone in chat said Skynet, which I think is probably what's gonna happen. Dr. Dahl, can I ask a big question?
Ooh.
Yes.
Why not?
Thank you for the kind words, Kevin. I wonder if shiny silk, oh, here, Justin3D mentions it. I wonder if shiny silk PLA messes with the detector. That's a good question.
I mean, we just got to get some of that PLA and
We actually
do a bunch
have
of
some.
models.
I ordered a ton.
Okay,
So
we can
we'll have some.
we just have to throw a bunch of data at it, and
Yeah.
it should be fine. But
as long as
getting that data is the problem.
Usually, as long as you get enough, as long as you get enough images or examples of something, it'll be able to train it. Like one of the things we were talking about earlier today is maybe even taking advantage of the fact that our build plate is so glossy and using it to, like, using the reflections to see around parts of the print that you normally wouldn't see with the camera, like, so that you can imagine like a bridge, right?
Yeah.
Being printed.
Yeah, I know what you mean.
Yeah, and like there's a failure inside underneath that the camera wouldn't see, but it would see the reflection.
That'd be insane.
Yeah, like that kind of thing is something we really want. I want to try doing. What is your dream 3D printer? Like, even if features not, sorry, like even if features not excited yet. What is my dream 3D printer? My dream 3D printer is just one that I don't have to use, like that I don't have to operate. Yeah, one that I can send files to and not have to touch. That's my dream. And I think it has to have a camera, obviously, for this stuff. It needs to be able to print. Well, it needs to have automation, and then with the automation, being able to print really fast is going to be cool.
That would be cool.
Yeah, because then I'd just be able to, pump out parts.
Oh, yeah.
Yeah, all day long.
I mean, I think that's anybody's dream.
I think so. Yeah, probably. Oh, Robert's here.
Hello.
Ooh, okay. Robert's going to get a kick out of our new, our impromptu green screen system. Okay, so why don't we talk about, like, our next thing is, like, we've been talking about automated data collection, like, so Leah isn't, sitting there punching the nozzle, causing layer shifts like this every couple of minutes. How are we actually doing it? And I'm going to put the slideshow of the failures behind us again.
That sounds good.
All right. So how did you do that?
Okay. Okay, that one was honestly just by itself. The bed was just like being weird.
Wrecked from
I think I just had it like not calibrated, it was not leveled properly. But most of like not even yeah. Anyways, most of the different prints that I've been doing, they've been altered with a script basically. So I would be slicing them into like normal G code. I haven't automated that yet. I'm not sure how I would yet. But anyways, once you have it all sliced up and in G code, you can input it into this script. It'll take it in and it will modify different lines of the G code basically. So I think I have like 5 scripts, something like that, and they do a bunch of different types of failure modes. I couldn't do all of them because some of them are like things that are to do with slicing, and like you can't really do that automatically. So that's like fine, but like at least half of them I think you can kind of force. So like layer shifts, you can like change where you want the G code to be, like it'll be shifted in a way. So like you can either have it so that you do it randomly. So I use that one a lot just because I don't want to think about where each failure is going to be kind of. So
Yeah.
it's just me being lazy, but I have made it an option where you can specifically place which layer you want the shift to be, let's say, and then like by how much in which directions.
So these actually what's showing now are layer shifts,
Oh yeah.
not this one.
Not this one.
But the
But
previous
before.
two were layer shifts.
But yeah, so basically it like reads through the G code, it like figures out how many lines there are, and then it can randomly select a number within those the line count, and then it finds that layer, and then it's able to
People are complaining about the footage. I'll turn it off for
Is
give
it giving
everyone a
them
break.
motion sickness?
Yeah.
You could turn the speed down, maybe.
Oh yeah, I thought that was a good speed. Sorry, guys.
I thought it was good too.
Yeah, I'll turn it off. But just so people can understand, like focus on your explanation because
Yeah.
it is really interesting.
Yes. So it finds like the layer, and
Mhm.
then once it finds the layer, it reads through it and like finds like a place to insert G code or replace G code basically. And then with that, it's just like putting it into a new file and naming it like the modified version. So I name each of the files like either like layer shift or like under extrusion, like whatever, things like that. So then when we're annotating it, it'll be easier to figure out what we're looking for in the image. So that's like another part, like how am I getting like the images with the same file name, stuff like that. That's like the
Yeah.
next part.
Yeah. So soon we'll be able to just send, like, have a G code, make 50 versions of it that all fail in different spots, and then send all those 50 to the queue, and then record the images and actually know, okay, we were recording this job, and this job has this type of failure that we intentionally created. And now, like, it's almost like the data is being self-labeled, which is really important because
Yes.
that's time out of your day otherwise.
For sure. Exactly. But
Do we
yeah.
have a photo of the labeling?
Um, I
Like,
think we had them, but they didn't go nicely into
oh,
the
they didn't look that nice?
yeah, they didn't, well, like it didn't match the rest of the pictures, so it was hard to
Okay,
like,
fair enough.
yeah. But it's
We can explain
basically,
it though. It's basically, oh, you explain
no,
it.
you can go.
Okay, okay.
You know.
So basically, you have like an image of your object on the print bed, and when you're manually labeling them, you just draw a box around them and say it's this type of failure. And then once you have enough labeled images like that, identifying where the failure is, then the model can start to get trained.
Yes, exactly. So we have that right now manually done for most things. Like it helps to know what I'm looking for at least. So that's really nice. But I think in the future we will try to automate it, even though it's like it's something that hasn't really been done in industry, I don't think, like automating that part just because it's kind of difficult for most applications. But I think there are a few ways we could go about it. Like one way we were thinking originally was to use a dual extruder printer and like having it do failures in a different color and then using
Oh yeah.
a different program basically that allows you to box just that color, and then it would be like labeled if you know what like is supposed to be in that picture. So technically that would be automated. It just would be really difficult to kind of set up, I
And then
think.
like it doesn't really, we were also, when we were talking about that, there's also, we were concerned that it wouldn't generalize, right?
Yeah, we weren't sure if it would, just because we would have to have really similar shades of colors
Yeah.
in like the failure and normal part of the
They have to
models.
be the same like luminosity or
Yeah,
something.
basically. So then when we grayscale it, then it would look like the same color when it obviously is not the same color.
That's crazy.
So that would be really cool.
Super
It's
complicated
just
though.
really complicated.
Maybe with automakers it would be possible because
Maybe.
their dual extrusion is pretty nice.
Okay.
Hmm.
Something for the future.
Something to think about.
So there is that, and then another way we're thinking, but you still technically would need some labeled by hand data to do this deal too, but it would basically have a kind of worse pre-trained model, which I guess we have now. But it basically using that model to guess on new data, and then with a human looking at the guesses, it could tell the machine if it's correct or not, and then you can actually feed that data in again. So in that way, it would be faster just because you're saying yes or no instead of like physically clicking on one corner of the failure, then the other,
Yeah.
and then there's multiple for each
Yeah.
different, like there's not only one failure usually in a picture, so you have like 5 different things to like circle basically, and then you like have to label each one, and you're like, wow, this is gonna take me a billion years.
And actually, we should mention like that already happens. That's how, if you've ever been asked if you were a robot and they made you click on an image and select all the squares that have like a run over cyclist in it, that's what you're doing for Google. So Google owns CAPTCHA. Those things are called CAPTCHAs. And what they do is they give you an image with 16 segments, and to verify that you're not a robot, they make you click on segments that contain certain objects. And what you're doing is actually labeling as a human the correct answer that then they will feed in. And the reason they use images of streets and street signs is because they're working on self-driving cars.
Of course.
And they need a lot of data for that. And so they're basically using CAPTCHA to farm out this annotation that Leah's doing to all the millions of people that use Google. And so yeah, it's like a very interesting model, but that's essentially what the annotation that Leah is doing is the it's the same thing as filling out a CAPTCHA basically.
Yeah.
And the CAPTCHAs are simplified too, because it's not like you can draw a box around the thing.
Yeah. It's like you have a set number of things you can choose and choose one of them.
Yeah, and actually, you know how I think they do it? They probably have, no, this is speculation, but this is how I would do it. If I worked at Google, what I would do is take one image, like with a stop sign, right? And say, tell people to pick the stop sign. But I would take that same image and I'd give it to like 100 different people, but I would shift the image slightly each time. Because then, depending on what square it's in, you'll be able to cut down it exactly to the stop sign.
That's kind of true. That'd be really smart of them.
I wonder if they do that.
I wonder if they
If
do
not,
that.
if not, then 3DQ's
Don't steal the idea.
Yeah.
Google.
3DQ's machine training system is yeah, our devs are more advanced. Maybe we should do that. That'd be so annoying. Imagine on login, every time you log into Quinly, you have to fill out, are you a robot? Detect all the spaghetti.
Losing people just to that.
Yeah, that would not be ideal. Justin 3D is saying, what are your thoughts on Quinly for Vorons in the future? That's a good question. There are some people in the Discord working on Clipper, which I think is required for the Vorons, at least to print really fast with them. So that's kind of what is, yeah, that's what's going on. We're trying to get Quinly to forward G-code into Clipper. But it is a thing. We're looking at Voron, and then one of the other printers that someone had mentioned to me recently is the rat rig, and I think Quinly would be a really good fit for that too. It's similar to the Voron.
Why are we black?
Google would charge you a lot for it and use the data, but H Captura would pay you for using the service, share profit for AI. Oh, that's interesting. So you can actually pay Google to put your stuff on CAPTCHA?
Oh.
I feel like it'd be
That's
so
even smarter
confusing.
for them.
Nobody would be able to log into their Gmail accounts. They'll be like, what is spaghetti?
That's true.
That's interesting. H Captura. We'll make a note. Thank you, Dr. Dahl. Dr. Dahl.
That's pretty cool.
Jack Greer, I have fluid currently under something. Okay, copy this. What a different. That's what's gonna happen with self-driving cars. Yeah. That's evil. Oh yeah.
Evil.
That's making people every time you send a job, you have to
That'd be so
annotate
sad.
5 other pictures. No, I don't think we can do that.
I would not wish that on anyone,
One thing,
knowing
actually,
from experience.
this might be interesting. One thing we're thinking about doing is when we implement this into Quinly, having it like rate your jobs after it's done, and then if it's giving it like an inaccurate rating, you can adjust it.
That'd
And
be
then
really cool.
that would help you track your production and your inventory quality, but at the same time, it would help make the model better. So that's something.
True.
I don't know. I'd be curious to know what
People thought of that.
yeah, what your guys' opinion on it is, because it would only make it better for everyone using it. And again, this model is intended to go in the free version too, so just keep that in mind. Have we hit everything yet? Yeah.
Oh, we didn't do the time lapse stuff. And like the art the
Oh, I guess they kind of saw that we had to turn it off because it's hurting people's eyes.
oh yeah.
But
I can
Leah's,
explain it.
yeah,
Though.
you put together a time lapse script, which will eventually go in, right?
Yeah, well, that'd be cool. Like, basically, what it does is it takes a time lapse of each job, and since we have specific parts of Quinly's APIs, I was able to get the job names kind of. So then each of the time lapses would be together in a way with under one of the names, and which is the job basically. So it'd be job first right now, or at least right now it's job, the printer's IP address. So if you're like printing the same job on like different printers, then you know which printer it's from. And then also like the date and time, just because you might be doing multiple prints on the same
Mhm.
printer. So you're gonna cover all the bases basically. So the names are really long right now, but it is very specific in a way. So
Yeah.
we have that going, and it basically knows when to start the time lapse by when heating finishes, and then after it sees that it's resetting again, it will stop the time lapse. And then we also have a video that it takes when it clears the part to see if it like cleared the part basically.
Yeah, and yeah, exactly. And so because you've already implemented that, we plan in a future update after the new UI associating these mini time lapses to your job history. So it can be useful for, especially if something goes wrong, it can be useful for like playing that job back and seeing where it got where it went wrong, so that when you are reslicing it, for example, you can be like, oh, this overhang here is where everything went weird.
Yeah, exactly. And for like this, us specifically, just for easier data collection, I have it so I mounted Google Drive to our Pies, and that allows us to just like automatically upload every like 250 images of the time lapse to Google Drive, so it's not like filling up the entire SD card basically. And then it's also like nice because it goes directly into the folder that I annotate from.
Yeah.
So I'm able to just like see it in real time on my
It's
computer.
very convenient.
Yeah.
Someone, Justin 3D was asking, does the camera quality need to be pretty good for it to work? No, it can be really bad actually.
Yeah.
The images get scaled down to 400 by 600. So like any webcam purchased in the last 12 years will work.
I assume so, yeah.
Yeah. Just like don't do it in pitch black, I guess.
Yeah, I always have like it kind of lit. I've tried some low light. It like is okay-ish, but I think if it's well lit, it will work better for sure.
Yeah, we'll probably have, actually, here's an example, but we'll probably have um oh, it just turned it off. We'll probably have like a recommended setup. I know Spaghetti Detective does as well, but you can see that we're trying to collect information in all light situations. Like this room
It's kind of dark, but then I'm
It's kind of, yeah,
shining a
this
light
is
on
your
it.
room, right?
That is
That's at
my mom's meditation room,
Okay,
and
so
she's upset that I've used it for this
it's
now.
a dark and tranquil room
Yeah.
full of spaghetti. Could the lighting be an LED on the hot end, or does it need to be more floodlight conditions? I think as long as you can see the surface
Mhm.
of the print, it doesn't matter too much.
Yeah.
Because the 3 printers that we've got dedicated to this at the office are actually um, there's like a big window, and so because we capture the prints over the course of hours, the lighting condition
Kind of
changes quite a
yeah.
lot. So we're trying to generalize it to avoid this issue of lighting.
Mhm.
And again, part of the reason we can even like consider that is because we'll be able to make so many images to train this model off of. So as long as you have enough images of these different lighting conditions, you can definitely yeah, you can have it work in many different lighting conditions.
Mhm.
We leave room lights on 24/7. Oh, that's true. We do, yeah, we don't take pictures at like in pitch black,
Yeah.
but it
Like we
will,
leave that room's light on
yeah,
usually.
that
Well,
will,
I put a sticky note there, so I'm hoping it
it
stays on.
stays. I'd imagine a light source is stationary. Oh, this is you, Steven.
That's me.
Yeah, I mean, stationary would be more predictable, but it depends again on the model itself, because if it's not looking before and after for context, it
Mhm.
doesn't really matter where the light is.
Yeah, like it should just figure it out by like the one frame that it's working on at that time.
Yeah. But if it was a video and you were like, your light was just spinning around, it would probably confuse it
Disco
so
ball
much.
lighting.
Yeah, be like, why is the printer rotating?
But maybe for large models, part of the model might become dark.
That's true.
So it's on opposite ends of the print deck.
Mhm.
That's a good point.
Mhm.
Yeah. I don't know how you'd get around that. Put like a mirror on the back side of the printer so you can see both sides of the print. That could actually work.
That'd be kind of
Why not?
cool.
Hmm.
More ideas.
More ideas. We have lots of ideas here. Can't see warping or anything. I think you would, because the vapor is pretty translucent, so you would
Mhm.
see shadows underneath. Um,
Yeah, I have some warping examples in there
oh yeah, we
somewhere.
do. Let me find
I took some good ones on the weekend, I think, actually, because I noticed when I was trying to print one of my parts in the tough white PLA, it was like warping by itself because it was
I
a
know
box.
there's a.
It's really in there.
Oh, here it is.
Yeah, there's a bit
Oh
of
my
warping.
god. Lots. Okay.
I
Yeah.
actually need more data on warping right now. We basically just need to print some weird filaments on like some widespread areas to get more data.
Just print really far away. As long as the part doesn't fall off.
That's
But
true.
that would probably, if you need help finding models that work, then.
Yeah, that'd be cool.
The other thing is that because of the way this works, you could even have like, it would start to detect models that are prone to warping as well.
That's true, which is cool.
Like anything with a weird, like the front of the benchy, the overhang,
Yeah.
it'll probably be able to start being like, there might be warping occurring here.
That's the cool thing about machine learning because it finds details that you might not even like notice.
Yeah.
But like it's a pattern to the machine and you're just like, I don't know how you figured that out, but okay.
Oh, good question. Diana was asking, what are the numbers next to the failure type? That's like the
confidence. So like it thinks that it's a model, like it's 70%.
75% sure that that is the model you're
Yes,
printing.
yeah. That's a good way to explain.
Like, I think it's 3 out of 4 times it'll be the model.
Yeah, basically. Like that
here
kind
it's very
of
confident. Like,
yeah.
That's for sure what I'm printing.
Exactly. So for different models, you're able to actually like change the threshold if you want. So if you think that your 30% is good enough, you can just have 30% on and it'll detect probably a lot more things, but you can just note that it's 30%. 30% likeliness that it is what it thinks it is.
Yeah. Like this one, if you had set the threshold to
50.
50, it would think it's a normal print.
Yeah.
So if it's spaghetti, you'd probably want the threshold pretty low. Or the model
Yeah,
would
this
need
is
to
an
be.
old model
Oh,
too,
this is
so
old.
it's not
It's
that
not as
good.
not as trained.
It's not very smart
Oh,
yet.
it got smarter.
You got a bit smarter.
A few seconds later, it's realized this is not what I'm printing. But yeah, there's also like, oh, okay, so we've actually arrived at our last segment, which is like, where are we now and where are we going with this?
Yes.
Why don't you tell them where we are now?
Where we are now is the data collection process, the most fun part.
The most tedious part.
Yeah, like at least like the way that we've automated it, the only parts that I actually have to do manually are looking through Thingiverse and slicing the G code to be put into the scripts. But that's not too bad compared to like literally trying to make it fail physically with my hands.
Yeah.
So that's been pretty good. Like the data collection honestly has been a lot better recently, and like when I first tried making this model like on my own, I was going through Google Images and like fix r slash fix my print and things like that, just trying to like scrounge together some examples of what I wanted, and I think it took me like maybe 2 weeks just going through all that and like trying to get data, and I probably got like 300 images. It was like nothing, and you'd think that you'd get more, but like after the first couple pages of some of these like results, it's
Yeah.
just like literal garbage and it doesn't help. So I thought that was like bruh.
Yeah, that was
And
very bro.
so now that we have like this system kind of, it's kind of
So much
nicer to
easier.
do the data collection, and now it's kind of pushed all the bruh kind of parts to the annotation. So annotating has been like the most time consuming now, but before it was like about the same as doing the data collection part, because I'd have to find an image, and then it'd be like, okay, I'll just like label it now because like there's only one image anyways. Not much more time. But now I'm like, I have so much data and I have to go through each of the pictures
Yeah.
to be like, this is a failure.
For those of you just joining us, Leah's collected 250,000 pictures of print failures in like a few months,
Yeah.
which is insane. Brandon's asking, are you only doing data collection in-house? Right now, we're only doing it in-house. We plan to, when it rolls out, we plan to do like an opt-in type system.
That'd be
So
really
if
cool.
you, because yeah, we know like a lot of people are printing top secret stuff, so don't want to infringe on privacy.
Yeah, that makes sense.
But yeah, it'll be opt-in, and it will only help everyone's detection get better.
Yeah.
Bullet time print failures. I'm excited. Yeah, we gotta do like Justin was recommending a matrix style setup, so we can do like bullet time, the camera's moving. Although 3D prints are like really slow, so we probably wouldn't want them in slow motion.
Even slower.
Even slower. What unexpected? Oh, this is a great question. Diana asks, what unexpected features for Quinly do you think might come out of what you've learned from this process? Unexpected. I know we were like pretty focused for why we wanted to do this.
Yeah, I mean, I feel like some of the things I didn't even think about like before this project came to 3DQ and everything, because I was trying to do this like last year all by myself, and I only really wanted to do it because I wanted to have something that could identify it, tell me, and then give me like a suggestion on what to do about it, because I didn't really know that many failures yet. So I was going through guides and I was like, if I could just like link a guide to like this detection and then it tells me or tells anybody then I thought that'd be really cool. But like I didn't even think about the automation aspect of
Mm-hmm.
it at the time because I wasn't at 3DQ. But like the fact that you could like automatically stop a print because you think it's failing and it just like it knows that would be insane. And then restarting it without you telling it to restart it would be even more insane. And then
Yeah.
I don't know, like just like the automation makes it so much better.
I guess for me, it was like the opposite. That when you brought this idea, because I had never thought about it, but it actually makes so much sense of like after after the failures detected, bringing up a set of guides to the operator, like in
Mm-hmm.
the software itself, and be like, here's how you can improve it, or here's how you can troubleshoot what we think is going on.
Mm-hmm.
Um, that was not something that I'd really thought about with this, but I think would be like a really massive uh, benefit because one of the biggest issues that's facing the industry right now is, or in the next couple of years as well, is going to be the lack of skilled labor. Because
Mm-hmm.
I was doing some math a few like I guess 2 weekends ago, and it's projected that in the next 4 years there's going to be 18 million FDM 3D printers out there.
Dang.
And if they're being run manually, it's going to require 4.5 million people to run based off of current numbers. And
Yikes.
there's no way that there are going to be 4.5 million dedicated print operators
Mm-hmm.
trained in the next 4 years.
Yeah.
So, um, what you had brought up, which is like linking people to the guides, helps bring the level of expertise, the the skill floor drops
Mm-hmm.
dramatically because they don't need to they're not spending so much time uh, searching online and gathering knowledge and
Yeah,
doing that because
exactly.
the software is kind of saying, hey, this is probably what's happening. And the nice thing is like you can see if what was suggested didn't work,
Mm-hmm.
then you can see, okay, well, maybe the suggestion that Quinley gave the operators is not a good suggestion.
Mm-hmm.
So we'll keep that in mind for the next time it happens
Yeah.
and suggest a different fix. And so that I think is going to be uh, pretty important as the 3D printer, like the quantity of 3D printers grows.
Yeah.
Um, yeah, but it was something, yeah, I hadn't thought about at all actually. But
We
it's
have the
more,
opposite
yeah,
ideas.
yeah. I mean, it's part of the reason. Honestly, it's part of the reason too. Like, uh, that the first versions of Quinly didn't even have a camera because I was like, oh well, it's automated, so you
Yeah.
don't need to look at the printer. And then you realize, well, actually, you kind of do because even though it's automated, you still want to
Kind of
make
just
sure,
check on it
yeah.
every once in a while.
Or if it's like in Robert's case, I won't say too many details, but his his machines are going to people who don't have experience running 3D printers.
That makes
So
sense.
being able to check in on the machine and make sure everything's going well from a remote side is
Mm-hmm.
very important. And so it's like that kind of thing where it's helping the operator do their job.
Yeah, exactly. It just adds on to the automation just because like you don't even have to go over to look at your automated printer. It's like you can just look at it from where you sent the parts from, basically.
Hmm. Yeah, especially as more and more printers get installed, it's kind of yeah. There's going to somehow have to be a reduction in the amount of time that people spend running their machines, and
Mm-hmm.
that's what we're trying to do. There has to be more than 4.4 million FDM printers out in the wild already. There have been more than 4.4 sold, but all of the industry reports I've looked at estimate that there are 4.1 or 4.4 running, like so that are actually in operation.
Mm.
Because I think they seem to assume, like I looked at I think there were like three industry reports, and I managed to get all of their projections to line up, and they had kind of assumed like a printer can be used for 3 years before it has to get decommissioned.
Okay.
And so that lines up with everything we've been seeing from like 2016 to now.
Mm-hmm.
And it also lines up with all of the report's projections for 2030, which is 100 million printers in operation, FDM, which is crazy. That is so many. You would need, what would you need? You would need, at current labor requirements, like at current time spent, human hours spent to run the machine, you need something like 20 million people. Yeah, it's like one person for 5 printers right now.
Damn.
Yeah. Or, well, more realistically, it's like one person to like 10 printers, and
Okay.
then another 5 printers were bought and used a little bit and then never used again.
Oh, sad.
Yeah, which is like what happens a lot of the time is people will buy a printer, mess around with it, and then just give up on it because it takes
Oh.
too much time.
You do that.
I know.
So rude.
Every under 3 someone got for Christmas.
Oh,
So sad. Let's see if there's anything else cool. That's an insane number. Yeah, 100 million printers is an insane number.
Deanna had a good question about will be a way to limit maximum number of repeated failures before fully canceling.
That's a good question.
Yeah, I think that'll definitely be
Yeah.
implemented.
I think what we're planning to do for like our more production focused features, like for professionals and stuff, is being able to set like certain thresholds for certain parts. So like if you're getting one failure out of 100, that might be acceptable. But if you're getting, something like 1 in 3 are failing, you might want to stop that production run. So something like that. And yeah, that's kind of on the list, is being able to adjust thresholds. There's some stuff I can't talk about yet too, that I think is like it's so far into the future that I don't think it's, but there's some like really, really interesting like workflow stuff you can do, and it borrows a lot from existing industries in mass production. But our challenge is like we have to take these technologies that are used for mass production and for like mass quality control, but they have to be generalized for any object that gets thrown at it, which is really difficult because from what I understand, these models that go into like industrial facilities, there is an installation period where you set it up for that specific purpose. Whereas a printer like has no specific purpose, like no specific part it's doing.
Yeah.
And so we have to make sure that the model can handle that kind of thing. Jack says he's running 19 printers. What is the uptime across all 19 printers is the question. Oh, unless it's the ones at his school. Good. Sorry, I'm just scrolling through the chat here. Benny has 11 printers. Actually, I'm curious if you're still watching, Ben, like, do you plan on getting more machines, or and if you weren't using Quinly, would you be able to handle more than 11 or 20 printers? We did a series of streams earlier in like around December with a bunch of Etsy stores, and an interesting pattern I noticed was they tended to cap out, so they would have like a massive amount of demand, but they would cap out at around 15 printers, and then their backlog would just start growing to like to be months because they couldn't manage more than that many machines.
I guess that makes sense.
Stacked. What tier of Quinly subscription will Okay, so Deanna asks, what tier of Quinly subscription will failure detection be included in? Failure detection is planned to be a free feature.
Which would be nice.
Yes. Oh, Steph already answered. Or Steven answered. Jack is definitely not married. Yeah, he's a couple years off of that. Okay. Jack will only marry in the industry. I can tell you from being in 3D printing trade shows. They're not.
I don't know, I wouldn't say there's many
It's a,
options.
it's unfortunately it's an extremely male-dominated
Yeah.
industry, but I think it's been changing. At least our company is not male-dominated.
I guess.
Actually, you can speak to that.
I guess so. I mean, I'm
I
kind
mean,
of
right
used
now
to it
there's
at
a
this
lot of,
point because
yeah.
I'm in mechanical engineering,
Yeah, true.
so it doesn't really matter.
Yeah. Surrounded by people who like play with screws all day.
Oh yeah.
Um, yeah, happy to keep on chatting if there are any other questions. Um, and maybe while I wait for those, I'll just do a quick recap for anyone that's just joining us at the end. But we've been showing off the culmination of 3 months of Leah's work, and I think
Mhm.
it's like super impressive what she's managed to accomplish. She's been building this model for detecting different types of failures using machine vision. How many types of failures?
14-ish. There's definitely more now that I think of, like the pillowing you were talking about
Yeah,
before. I'm like, there gotta be more, but
but built in, you've built 14 of them into the
yes,
model
yes,
so
yes.
far, into the first iteration, because we plan on improving this.
You can always improve the model too, which is nice.
Yeah, so we've got these 14 modes of failure that we're looking for, and you've set up an automated using Quinly. You set up a way of automatically making bad G code
Yes.
and queuing up dozens and dozens of bad G code prints, and then automatically taking photos of them and associating photos to the print jobs. And then that helps you do things like um, annotate the failures, which
Yeah.
is what we need for machine learning. And so far, over the last 2 months or so, you've collected 225,000 images. And so far, we've only annotated 1% of them.
Yeah. That is the only problem.
That is the
I
only
mean,
problem.
that's something that can be improved in the future as this model improves as well.
But the nice thing about it is, even with only 2,000 images annotated, we're getting some pretty good results already. And we have 100 times more data to work with.
Yeah.
So that means it's gonna be 100 times better, right?
That would be nice, but we'll see about that.
Marginal return. But yeah, so that's awesome. And what we plan on doing with this is, because the printer will finally be able to know what's going wrong, it'll actually be able to respond in very smart ways and help take the work off of your back, so you don't have to constantly watch your machine, um, as well as some of the easier things can be taken care of for you, like marking certain prints as failed, or stopping a print and having you inspect it or try to recover it, or just aborting a print and restarting it a few times to see if it can get it going, that kind of thing. Things that would typically take you a lot of time, and things that you would not catch immediately as well, which just wastes print time, because you often catch failures late into the part. You also generate a lot of waste, which is not good. And we want to catch these failures as soon as possible to lower part costs, to lower waste, to be able to keep your production schedule on track.
Yeah. Also, just saving your printers from some not very nice things happening to them. I mean, that nozzle, though, that I think Joe might have to fix later.
Yeah, I see you got a full no extrusion on this one.
Yes.
Was that intentional or was that not intentional?
No, that was intentional, because
Okay,
it's like, I mean, you can't see in this picture, but because of how large the letters are, but it's actually like fully not on the print anymore. It's like
it's
this
floating.
much off. Yeah, so that's kind of nice.
And then, yeah, as Dana points out, one of the other things we plan to integrate, other than just responding on a job level, is actually responding on a G code level. So if we're detecting things like under extrusion or over extrusion, trying to fix that while the model is printing, maybe even down the line, like trying to fix position errors or adjust temperatures,
Mm-hmm.
things like that, in order to compensate for potential issues. I can see like if you have really sparse infill,
Mm-hmm.
lower the infill speed,
True.
something like that. And then on the back end of things, when a print is done or when a printer is having issues, notify the operator of like, here's what the issue is and here's some possible solutions to it so that they don't have to spend time doing research or have to have like years of knowledge and experience
Yeah.
in order to know what these weird different failures are even called. Like it's pretty crazy just how many different types of failure there is. Um, what else? We plan to release this for all Quinly users, paid and unpaid.
Mm-hmm.
Um, and yeah, we hope to just like continually improve this system. What else do we have?
I don't know.
That's pretty much
I
it.
mean, we went through everything basically.
I think that's a good summary.
Went through all of my 3 months of work essentially.
Yeah, this
so.
is your defense.
Yes.
Defense. You're presenting to the chat, and now they have to say whether you graduate or not.
Oh yeah, exactly. You got to grade my co-op.
Oh yeah. Everyone in chat, if you think Leah did good work, drop a like on the video.
Oh no, 0 likes.
It'll be out of 100.
Oh no.
Jack Greer is saying ASMR, please. I don't want to ruin
It ruined the stream.
the end of the stream. But Jack made some beautiful ASMR print videos, and if you join our Discord, I'm sure he would love to show you. I listened to it for like 5 seconds, and I was just so satisfied I had to turn it off immediately.
Yeah, that sounds likely.
Yeah. Yeah, definitely join the Discord. Keep in touch with the community. Some people have already heard about or seen this too, and we'd love to get more ideas. Like even in chat, a whole bunch of you were making suggestions that I think will be really cool. And like with everything that we're designing, we're working really closely with all of you. And like you'll see in the new UI, which has been sent to some people for testing already. So very, very, very soon, I promise. But yeah, we made it with you guys so that it works for the way you all are planning to use this. Yeah, so definitely join the Discord or send us an email if you want to keep up to date on the things we're doing. I would definitely suggest joining our mailing list or following us on social media or subscribing on YouTube or joining Discord, because in Discord you can actually bug us, but we'll respond to comments everywhere. There's one more thing I want to mention. Oh yeah, keep an eye out for some interesting news regarding metal 3D printing and Ultimaker. Yes, we've leaked some stuff before, but there's going to be some interesting news coming out, and we'll probably have a stream about it.
Ooh,
Yes.
that would be cool.
Oh, also, I don't know if any of you guys watching are planning to attend Rapid TCT, but keep an eye out for us there. It's a big 3D printing trade show, and they actually have tickets online for it. So I think we'll probably be posting details in our Discord soon. I think we might have, I won't say too much because I'm not sure, but definitely see if you can attend, because it's like going to these trade shows, even if you're not, in a big company or whatever, it's super cool to see all the like cutting edge stuff in 3D printing, and the tickets for just attending are generally not very expensive. Oh yeah, any Labor Day sales you can talk about. Oh, good prompt, good prompt. Yes, there is a Labor Day sale on Monday. Um, I think for all Quinley kids. So definitely keep an eyeball out for that. There will be a discount on Labor Day.
Question marks.
Yes. To answer your question, yes. Thank you for reminding me. Robert asks, is Leah staying on the team permanently?
I mean, I have to go back to school. I'm sorry, guys. It's not like I want to go back to school. I'm not gonna lie, but
We'll be in touch.
I see. I see.
Yes.
Hint, hint.
Hint, hint. Yeah. Yeah. You still how many terms until we graduate?
I think like 3.
Oh
I still have a lot of time left. I'm
Just-
not like Steven,
can you
who's
take-
already graduated.
Yeah, just take 10 classes a term, please.
I'm already taking so many extras just to make my 4th year easier, and it's like just
Oh.
normal now.
That means you can work part-time in 4th year.
Oh my god.
Hey, I did that.
Yeah,
Did
that's
you?
what Steven did.
Okay.
He
Think
worked with
about
us
it then.
for
All through 4th year.
yeah, you did 6 months co-op and then all through 4th year.
There
And
we
now where are you
go.
working?
I'm working here.
Oh, okay.
Oh, okay.
Full time?
Yeah, full time.
Nice, nice, nice.
I'm actually working right now.
Whoa.
Yeah, we are too. Speaking of which, we should probably get back to work. So thanks everyone for joining. And if you guys are catching the replay or anything, come join our Discord and keep the discussion going. Other than that, we're back on our Wednesday times.
Oh, we
So,
are? Wow.
Yeah, we've moved
There
back.
we go. We've come full circle.
We've come full circle. But yeah, check out the Labor Day sale on Monday. Stay tuned for that. Make sure to, I think, watch out on Instagram and the mailing list, and of course Discord. Benny can keep his artificial eye out for the deals that are coming up.
Interesting.
We'll be around next Wednesday, same time. Bye.